Bonjour, comment ça va? Ça va bien? So my name is Ben, and I'm here to talk about JavaScript errors. Really, this is kind of a deep dive into the error object and how stack traces are generated, and a whole bunch of that, so we can come away hopefully learning a little bit more about how errors work, so we can use them more effectively in our own applications. I work for a company called Sentry. We're one of the sponsors here today. Sentry is a mostly open source platform, web service and client library collection for servicing errors from many different platforms, be they node.js or Ruby or Unreal Engine or iOS. Obviously, here to talk about JavaScript. If you are curious, it's very simple. You just sort of npm install a library, initialize that in your Express application or browser JavaScript application. And once you do that, once any kind of errors are thrown, you kind of get these really nifty dashboards that give you, stack trace with surrounding source code, event volume, etc. It's on GitHub. You can run it yourself. I'll talk a little bit more about it at the end. Oh, there's some other screenshots. So if you've ever struggled with situations like the following, where maybe you're looking on your console or an error tool like Sentry and you see uncaughtException, what does that mean? Not very helpful. Or maybe you've got an error and it's just a message and there's no stack trace, very frustrating. Don't understand how that happened. Or you've seen this. This is like a browser JavaScript error called script error, in which you know that something's wrong, but that's pretty much as far as it goes. If you're suffering from some of these symptoms, I'm hopeful that we can learn some things to fix that. So in this talk, I'm going to talk about the error object itself, how you can extend that to create custom errors, the stack property and how stack traces are generated, what does it mean to throw other objects besides errors, and then a little bit about, now that you know how the error object works and how you try and catch them and all this jazz, how can you report on those errors to like a logging facility or some other tool. So if this doesn't interest you at all, you should make way right now. So the error object itself, where it all begins. So this is from MDN. The error constructor creates an error object. Instances of error objects are thrown when runtime errors occur. The error object can also be used as a base object for user-defined exceptions. Pretty concise. Really want to focus on that instances of error objects are thrown when runtime errors occur. So what that means is that, let's say that you have code like the following. It's written sort of backwards. That's intentional, but just take a moment to read it. It's kind of like this cascading waterfall of function calls where A calls B calls C, and then C calls this function D, which doesn't exist. And as we all know, that's probably not going to work. Something's going to happen. And it's going to look like this. Uncaught reference error. D is not defined. This is what you'd see, maybe your node application will just stop and throw this out, or you'll see this in the browser console. Thing is in the background, if you were to do this instead, you can actually throw your own reference error. There's nothing special about that. It's an error object that exists or is subclass from error, and you can throw it. And if you did this, it's the exact same stack trace. You wouldn't know the difference, okay? So all this is to say is that when you actually, throw a runtime error like this because your code doesn't execute, behind the scenes, it's really just creating an error object, instantiating it, and then throwing it. So you don't have to, obviously, you don't have to throw reference errors. You can throw the base error object itself. And if you do that, you can see how the output is a little bit different. In this case, you see uncaught error. This is super broken, but the same stack trace generates from that point. The error object has like three major components. In my mind, it has the names. That's like, just as we saw reference error, that's the name of the error. It's actually a property on the error object that you can inspect. There's the message, and that's the first parameter that you pass to the error constructor. And then the stack is also a property. And these are like actually values that you can inspect on the error object itself. So if I went back to that example, and if instead of throwing the error and sort of like letting that bubble up to letting the program crash, I instead try and catch it, I can inspect the values of that error object and output them to the console, and you can see that they look like this. So just that you know that these are things that you can navigate and inspect yourself. There's a bunch of standard errors that are kind of like built into JavaScript. I don't know if all these are in Node. They certainly are in the browser, right? For example, URI error. That probably exists. Not sure. But these all derive from errors, and they sort of are built into the runtime. Some of which you may have not seen before. Internal error is when the actual underlying JavaScript engine has exploded in a way that it doesn't quite understand. So if you do see that, it means that V8 is not happy. Eval error happens if you try to run eval in the global scope, things like this. You could use these yourself if you wanted to. Again, they're not protected in any way. You could throw them yourself. What is perhaps more practical, though, is to sort of extend the error class yourself to create your own custom error classes that might actually add more contextual information that you might want to add. So in this very simple, super simple example, all I'm doing here is extending the error object and just giving it a different name. You actually have to overwrite that name property. JavaScript doesn't magically know to look at that class variable and to sort of transport that to the name property, so you have to declare it yourself. And now you can throw this error, and it will do just as it will operate the same way as every other error example we've seen. Okay? This example right here doesn't really do much other than to create a new name of an error. That could be useful. Maybe a more useful example is if you were building an API, and you could create your own error class called the API error class, and you could augment that, add a status code. Maybe you could add some headers or some other values. And the reason you would do that is that maybe when you're inspecting these values later in your application, you're dumping them, you're console logging them, you can actually output that information, which could tell you a little bit more than just sort of a stack trace. Below, this is sort of an example where you can try some code, you can catch it, and you actually see if it's an instance of this API error, in which case you can sort of that you can carefully extract that status property that wouldn't otherwise exist. Okay, so that's just the error object. It's nothing too crazy. I think the most interesting part is the stack trace. It's the most useful thing. It shows us what were the frames that were executing before the thing broke. It's the thing that's going to tell you where your application stopped working. So like I mentioned, it is like a property on the error object. It's actually like a prototype property. So how does a stack trace get generated? Some people, I don't know, if you're not aware, the stack trace is actually generated at the moment at which the error object is instantiated. Some people might believe that it's actually when you throw the exception, as in the examples that we had. So if you have this example, looks like earlier, the difference here is that I'm creating an error and then I'm returning it through the function waterfall all the way to the top and then throwing it there. The throw point doesn't matter because the error was created in that C function. The stack trace that you can see there in the bottom right still kind of cascades the same way. So the big takeaway is that it's on error creation is when the stack trace is generated. But that means that this is a pattern that sometimes we use in application development, which is to sort of like catch a generic error, and because we know more about it, we might rethrow one of our custom errors. So for example, what if I caught an error and then I rethrew my API error, and I want to add like a status code? If you do that, oops, sorry, getting ahead of myself. If you rethrow an existing error, you won't actually change the stack trace, right? So I can catch it, I can throw it again, and there's no problem. It'll look exactly the same. So you can catch and throw, the stack trace will still originate. This is what I was getting into, which is if you rethrow this as a new error object, right, like my custom error. I was getting ahead of myself, sorry. In this case, you actually generate a new stack trace. And that's because you've created a new error object instantiated at that point. And this can be problematic if you're doing this like not carefully, because you're actually eliminating all that original context that you were catching. So something to be aware of. If you've ever dealt with a stack trace and you feel like it's missing frames, this is a possibility. What you can do instead is that if you are throwing your own custom errors, you can actually copy over the original error stack trace onto that new like custom error object that you've created. In this case, I'm calling it like original stack. And this way you kind of get both. You get the stack trace leading up to your custom error, but you also get that original stack trace that bubbled up. You can also just completely overwrite it if you want. There's nothing stopping you from doing that. Everybody following so far? Going too fast? Okay, a lot on it. Good. Yeah. So everything that we've been talking about so far are these synchronous code examples, but we all know that JavaScript has like a lot of asynchronous code. It's one of the things that makes it cool, not challenging. One problem with that is that the stack property, it really only bubbles up to like the topmost asynchronous frame. So let's say that we have the same example. A calls B, B calls C, but then C kind of breaks out this set timeout function, which queues up a call that gets executed asynchronously. And then in that function that gets executed, we now try to call the function D, which doesn't exist. In this example, unfortunately, you just get this. Okay? The fact that there was this sort of like, cascade of function calls that queued all this code up, it's lost. And that really stinks. Very frustrating. This is something you should keep in mind. Now, you might be thinking, this is a Node conference. I've heard a lot about Node 12. It has asynchronous stack traces. This is a thing. Full disclosure here, I'm not like a full-time Node developer. It's more of a curiosity for me. I'm mostly like a browser JavaScript developer. But I was playing around with this, and this example right here, if you try this in Node 12, you'll actually get the same result. You've lost sort of like that, the outer context calling that set timeout. But there are some patterns that you can use in Node 12 which actually give you like a full like asynchronous stack trace. So if you're using promises, you're using async await, and you have this example, which is it's actually very subtly different from the other one. Node 12 will sort of provide you this asynchronous call stack. It doesn't capture every sort of asynchronous call stack. There's just sort of like particular patterns that it's aware of in which it can generate this. And it's usually using async and await. Chrome, however, if you have devtools open and you use that earlier example that I had, this example doesn't try catch the like runtime error. It instead just lets it explode. If you run this in Chrome today in devtools, you actually get this really nice output that is pretty handy. It shows you, it has a different format, but it shows you these sort of like asynchronous calls. And this is really great. This gives you kind of everything you need to figure out why the code was broken. A challenge here, though, is that this is actually just like the developer console. It isn't actually, even though Chrome and V8 kind of has all the information it needs to sort of augment that error object with a stack property that would have this information, it doesn't. This is strictly just what you get in the console output. And if you were sort of like logging this in the example that I had before, you'd lose these frames. This is all really silly, okay? So like obviously like different runtimes interpret error stack traces in different ways. And that's because this property, this stack property that's so useful that we've depended on, it's actually non-standard. The presence of it, the idea that it exists, that there is some property named stack, that is standardized. But what is inside of it is sort of like a free-for-all. It's not defined. So perhaps in the future, all those asynchronous sort of like patterns will emerge, or they'll get like extended onto the stack property for the error object. And that would be fine because it's not standardized, so there's nothing really saying that it can't. What that means today is that if you look at stack traces from different sort of like browsers and different JavaScript runtimes, they all kind of output these stack traces in different ways. So Chrome, V8 sort of output, for example, they redundantly output the error name and the message on top of the stack. So this is me just outputting the stack property. It includes that redundant information. Safari omits that information, has a different way of sort of like showing you frames. Firefox has another way as well. What this means is that if you're doing sort of like error reporting and you want to kind of like group different errors together, you have to do a whole bunch of like regex massaging and things if you were so inclined. So stack property, couple key takeaways. It's generated instantiation. Rethrowing the same error will not generate a new stack trace, but if you create a new error, obviously you will. The first frame is the topmost asynchronous execution, except for in some cases, it's just a string, right? So everything I've shown you, this is not some clever array that you can manipulate. It's just all string data, and it's non-standard. So far I've been showing these examples where we throw errors, which is like the really good way of throwing things if you want to stop execution. In other languages, if you try to throw or raise an exception using a non-error object, that act in of itself will create an exception. So in this example with Python, if I try to raise a string, it basically is like, whoa, you can't do that. That's not how this language works. JavaScript, however, is perfectly quite content to let you throw anything. So in this example, similar as before, I have functions A, B, and C, and then I throw this string called oops at the very top. If I do this, and I try to catch it, and I try to log it, you just get this. You just get the string oops. There's no stack trace, there's no message, there's no nothing. And so if you've ever been logging errors and you see just random strings or things that you don't understand, oftentimes this is the case. It doesn't have to be a string, it could be an object, just like any non-error object or nothing with a stack property, you'll get something like this, object, object. Now, it's not very common for people to say, throw a string. What I think is more common that I've seen is that when people are doing promise rejections, they might say, hey, I'm going to reject this promise with a null value or -1 or something. And if you do that, it's the same story. You're kind of deriving yourself, or not deriving, you're preventing yourself from doing post hoc debugging of that data because there's no stack trace. So if you are working with promises and you have an opportunity, you should create error objects as opposed to just resolving things with primitive values, or you don't know. There are global promise handlers that can help you find things that don't resolve. So that's only going to be a useful utility for you if you actually have a stack trace to help you understand where those rejections occurred. If you know that this is happening in your code, you'd like to stop it, there are actually some ESLint rules that you can add to your software code repository right now that'll look for these patterns and encourage you to resolve promises with error objects. And if you're interested with that, there's no throw literal. That's for preventing you from throwing strings and objects. And then prefer promise reject errors is another rule you can use to stop that. So earlier we learned about how you can use this fact that when you create an error object or you instantiate it, you actually get a stack property. You can use that in useful ways. So in this example, let's say that you know that you have a string that's thrown somewhere. And this is really challenging because you don't know where it is, right? This is a very contrived example where I'm throwing a literal value, but what if you're throwing some variable that's being passed around, right? Very hard to track down. A technique that you can use is that you can try and catch some problematic code. And if you know that this error is not an instance of an error, you can actually throw a new error at that point in time, in which case you'll kind of generate what I call a synthetic trace, where you've created a stack trace up to the point where you caught it. And that's not obviously it's not going to get you all the way to the root of your problem, but it at least gives you kind of a starting place. And from there, you can kind of add more try-catch statements with these synthetic traces to kind of get you closer to the problem. There's other useful ways of using this stack property. If you just want to, you don't have to throw an error, right? You can just create an error object, console log the stack, or put the stack properties, preserve it in a way that is useful for you, and toss the error away. That's perfectly valid as well. So non-error exceptions, they're caused when you throw any non-error. They make determining root cause difficult because you have no stack trace. Promises, common source of them, and you can use this error object to help you out. So up until this point, I've kind of been talking about the error object, ways to use it a little bit more effectively, or at least to understand how it's operating so you know what you're looking at. And I talk really briefly on just what if you want to report on those errors? Here's a really contrived example. If I try some code, problematic code, it blows up, I can catch it, and then I can use fetch or node fetch to send some data to an error reporting endpoint. This could be a logging endpoint or something you've stood up. I'm not going to go into the details of that. Of course, you don't really want to pepper your code with try-catch statements, especially because try-catch only works on asynchronous boundaries. You'd have to do it all over the place. So most JavaScript runtimes provide you global error facilities, error collecting facilities that you can use to collect them. In Node, you can use process.on uncaughtException, and you can use that, catch an error, try to make a HTTP request somewhere. But if you do this, you should be really painfully aware that this actually subverts the your program halting. So you have to do it yourself, and the docs will tell you that you should really only run synchronous code in this error handler, because if it doesn't exit, there's a chance that your application might be still running in some sort of undefined state. while you're trying to do cleanup. So something to keep in mind. Like I would argue even this really contrived example I wrote is not very safe because it's basically saying, okay, the program halted. I'm just going to send this error report somewhere. And while I'm waiting for that to return, my application is going to run in an undefined state, and then I'm going to process exit. But I just wrote this as just like a really contrived example because dealing with this in a safe way is too complicated for one slide. Similarly, you can use that same sort of event handler for unhandled rejection. The callback for this is it takes a reason, which is, why was this actually, why was this promise rejected, which is typically an error. And if it is an error, you can, of course, extract it and send it, just like in the example before. In this case, this doesn't halt operation of your program, so you can kind of do this much more safely. In browser world, it's a little trickier. Browser world has this window.onerror global handler that is really like a relic that dates back all the way back to the 90s, and so it's sort of just kind of we've just been tacking on parameters until it's been useful. So, in order to preserve backwards compatibility. So that's why it has all these arguments. So if you're curious, the very first iteration just took like a message, and then it took a URL, then it took a line. Then we're like, yeah, a column would be useful too. Let's throw that on there. And then finally, we just sort of added this like final fifth error object that actually contains everything. So just like before, you can, on window.onerror, you can kind of send this data somewhere. The browser also has an unhandled rejection global error or global rejection handler. It has a little bit different signature than what we saw earlier. It takes like a promise event, and on that event there is a reason value that hopefully is an error object, and you can report on it that way. And also what's really cool about this is Firefox in the last couple months just added support for this. So it's actually a relatively newer thing. But now every browser supports all of these global error tools, which is pretty cool. One quick example, I do want to bring up that in Node world, listen, you run your whole environment. It's very easy. You just collect errors, throw them somewhere. Browser world is a little tougher. Here's an example of actually using this on-error handler where I'm loading a script with my example code. And very importantly, this is coming from a CDN. So I'm pointing, it's very common for us to publish static code onto CDNs these days, whether that's Netlify or something else. And if you do this way, you might come into this problem where if I throw some code, instead of getting the stack trace, all this cool error object that we were talking about, you don't get anything. You just get script error. Okay? This is a problem that a lot of people run into when they're configuring this, so I think it's always worth taking a minute to talk about. It's very challenging because it is basically omitting everything. So that null object that I've kind of highlighted in the output, that's the error object. So the browser has actually said, you can't see this. We're not even going to show you what the error is in this situation. And the reason it's doing that is because of the same origin policy. So same origin policy is this sort of policy that makes it so windows and tabs can't talk communicate between domains. You don't want to leak information from your bank website to some other website. And this actually extends all the way to global errors. And this kind of makes sense if you think about it, because what their fear is that if you can load a script from another website and you're actually authenticated on that website, then it's possible that an error might be thrown from that website that contains private information about your account, right? Uncaught error, user Ben Vinegar, whose account details are 1, 2, 3, 4, 5, 6, 7, 8, 9. This is their password. That's obviously super contrived. I don't imagine that would happen, but it is a possibility. And so for that reason, if there's an error that would come from a script that's hosted on another domain, it actually gets sort of basically blanked out with the script error. The way to get around it is use CORS, if you're familiar with it, cross-origin resource sharing. And you have to do it in two ways. If you're requesting this script from a CDN, you have to set this attribute called cross-origin equals anonymous. That's actually a signal to the browser to say this is the expectation is that this is sort of a cookieless domain. You can just request this. There's no session information. And I believe the browser literally doesn't send cookies if you sort of request a resource this way, if it's set up this way. And then on the other side, from your CDN or whatever's web server that's returning this script, you have to actually declare that any origin can request this, right? So you say access control allow origin asterisk, or you can lock it down to a set of domains that are trusted. And this is sort of like, it's almost like a handshake, right? The browser is saying, I'm not going to request anything with session information. And the server is also saying, I have no expectation that there will be any session information here as well. And once both of those things have to happen, then this example that I showed you earlier, it'll work. You get to actually see errors that come from other domains. So just something to keep an eye out for. So it's kind of like the end. What did we learn? That's a good question. I don't know. You can use custom errors to add meaning to failures if you're not already. You should keep in mind how stack traces are generated, because if you're logging them, you might have a better idea now of kind of like why does it have this shape and where did the error occur from. Don't throw strings, objects, or other non-errors because you'll find yourself in this very problematic situation where you don't know what's going on. And you can use global exception handlers to report errors if you want to. This is, of course, the part where I suggest that you shouldn't do that at all. You should just use like a tool that does it for you, because it's really complicated, and I don't have enough time to go over the ways in which it is complicated. So Sentry is, this is kind of what we do, and it's a source available software. So that's basically, it's like fully permissible for you to run, modify yourself. You can run it on your own servers. It is on GitHub, on github.com/getsentry/sentry. It gives you cool error reports like this. I usually don't mind pitching this because like the whole idea here is that you can run it yourself. And here's a kind of an example of that it exists. We have a booth here, and if you're curious to see what it looks like, I'd love to talk about it. If you thought any of this was interesting, you want to learn, just go a little bit further into, how does our Sentry JavaScript library work? You could go ahead and take a look at the source code over here. If you are curious more about the script error thing, or you want to do your own error collection, I've written some blog posts that you can check out. So that's it for me. I hope this was okay. Thanks so much for being here. Merci beaucoup.